All right. Thank you. Okay. So we'll start with Sri Gurubhyo Namaha. Salutations to our gurus, Swami Dayananda Saraswati ji, Jai Kumar ji, and Raj Vedam ji, who have been an inspiration for this branch of knowledge.
Although you are
And
not sharing the screen.
You're not sharing,
uh,
Madhu.
okay, all right. Good now.
Yeah, it's coming up. Yes.
Okay. Let's start with the Shanti mantra. Asato ma sat gamaya, tamaso ma jyotir gamaya, mrityorma amritam gamaya. Om Shanti Shanti Shanti. Okay. Uh, okay. So before we go to today's class, I think Ajay has something to share with us. We will cover that quickly and we can move over to the today's class. Ajay, over to you.
Okay, I
Let me
think
stop my
you might
sharing.
have to stop sharing. Yeah.
Yeah.
Okay. Yeah. So this morning, I got up and I went into the backyard. Can you see my screen?
Yes. Do you want to put it
Okay.
on presentation mode?
Yeah, sure. And I saw this constellation, Orion, which, normally the constellation is something, the Orion is something you would see in the winter time in the evenings, but it came around early morning now. Maybe in a few months it'll come later, but it was very clear, and it's a very prominent constellation. It's got these two prominent stars, two bright stars, Betelgeuse and Rigel. So I'll just and it's in Greek mythology, Orion is the hunter, and in Indian astronomy, Indian is also known as Mruga or the deer, and sometimes also associated with Shiva or Kalapurush. And Rigel forms part of the Nakshatra Mrigashesha, and Betelgeuse form is the principal star in the Nakshatra Ardha. So now, interesting part of Orion is it's a very active constellation in some ways, and if you see the constellation, there is again, if you imagine it's a hunter with a bow and a belt, there is a part of the hunter which is known as the hunter's sword, and in the sword, there are three stars, and the middle star is actually not a star; it's a nebula, and it's a birthplace of many stars, and it's about 1,500 light years away. And it's pretty massive. It's about 25 light years across. So it has a pretty big size as compared to the sun. So this morning I just pointed my um, uh, telescope towards it, and uh, just towards the middle portion, middle star, and you can see that you can actually see the nebula and nebulae in that area, which is pretty visible. So this is using my C star S50 that I had an exposure of 15 minutes. Probably I need to have a larger exposure in order to get an even clearer view. But then the sunrise was coming up, the sky was brightening, so I couldn't see it beyond that. But you can see pretty clearly the nebula, which is also known as M42 or the Great Orion Nebula. So I just wanted to quickly share that before all
Yeah.
this starts.
Thank you, Ajay. I believe this is also called as the pillars of creation, if I'm not wrong,
Yeah,
because it's a birthplace of many stars. You know, these nebula coalesce
exactly.
ultimately to form the future stars. And also, there is a very interesting story behind this Mrigashirisha constellation. You know, the Orion Mrigashirisha, uh, which kind of connects to the Chandra's 27 wives, right? So if you take the belt of Orion, and if you trace the locus of that Orion, on one side it goes towards Sirius. So you can actually
Yes,
go and see it in the night sky itself. You draw a line towards the three stars of the Orion belt. It on one side it goes and points to the brightest visible star in the sky, which is Sirius, which is the dark star, right? Now, if you drag it on the other side, it actually goes to. Can you take a guess where it goes? It goes to a star called Aldebaran, which is incidentally the Rohini Nakshatra in our
Okay.
Indian astronomy, right? So there is a nice
Mhm.
story that see Rohini is the one of the 27 wives of the moon because the moon goes through the nakshatras, and then this hunter. There is a metaphor behind this Orion Hunter constellation in our Indian astronomy, which I think is uh, Lord Shiva as the hunter, Pashupati, right? And there is a story that connects these two. Maybe we can touch upon that when we get to that section of the course. But I just want to kind of let's say give this teaser right before we can discuss. There's a rich metaphor behind the Orion constellation, the Rohini Nakshatra, and the entire Mrigashirsha area of the sky, right? So we'll probably touch upon that. Okay, so we can get to today's session. Let me share my screen. Okay, I hope it is visible now. Let me put it in presentation mode.
yes, all good.
Okay, I don't know what I did. Sorry. What are you seeing now?
I'm
Are
seeing
you
the
notes?
notes, your notes.
The notes.
Sorry. Let me come out of the slide mode, then share it. Okay. Okay. I think this should be fine, right?
Yes, it is.
Perfect. Okay. So today we will quickly do a review of the previous classes assignment, and then we will touch upon the Indian Astronomical Model. Now, obviously, the Indian Astronomical Model is a huge topic in itself, which covers various aspects of Indian astronomy, uh, such as the uh, precession of the equinoxes, which we will go into a little bit more detail today. And then there is this whole reckoning of time, right? So, what is the concept of time in Bharatiya astronomy? I do not think we will have enough time today, so we will take it up a little bit later in the course, right? So, quick assignment review. First of all, thank you to everyone who submitted the assignment. Uh, so, uh, so let's quickly review the questions. The Vedanga Jyotiṣa text provides an important astronomical marker for its time, stating that the Uttarayana begins at the start. Now, Many of you had actually said it is Aslesha. So it is actually Dhanishta, right? Uh, so just to refresh our knowledge on this, I just take you to this slide where, if you look at it, summer solstice, so summer solstice happens at Aslesha. So typically your June 20, during the times of Vedanga Jyotiṣa, June 21st would have been Aslesha, right? And then the Dakshinayana starts there, right? So so as the sun traverses from Aslesha to these nakshatras, Pushya, Punarvasu, sorry, uh, Aslesha, summer solstice is present, and
Nagam,
then
Magam,
sorry,
it goes that way. Yeah.
it actually goes this way, and from Ashlesha to Shravana, or to the end of Shravana or the beginning of Dhanishta is the Dakshinayana, right? Uh, and then the other way around, which is from Dhanishta to Aslesha, going through these stars, right? Satabhisha, Purva Bhadrapada, etc. is the Uttarayana. Right? So if you look at this sloka, the sun and moon start moving north at the beginning of Sravishta, right? So the northern movement, the Uttarayana, is actually happening at the beginning of Sravishta. The sun starts moving south, which is the Dakshinayana that is happening at the middle of Aslesha. And this happens during the month of Magha and Shravana, respectively. So that's just the month names, right? So that's fine. The nakshatras are actually Dhanishta, where Uttarayana starts, and Aslesha, where Dakshinayana started during the time of Vedanga Jyotisha. So I just wanted to clarify that. Now, let me just go forward. Uh, which astronomer is credited with authoring the influential text Siddhanta Shirodamani? I think this is quite straightforward. Bhaskara too. Uh, and Varahamira's Pancha Siddhantika is a compendium of 5 Siddhantas, including the Surya Siddhanta and the Romaka Siddhanta. So that's also straightforward. And which of the following texts represents the earliest stage characteristic of Bharatiya Astronomy, characterized by observations encoded in ancient poems? That is Rigveda. So I think these three have been answered by everyone. I think the first one, there was probably some confusion. So the answer is Dhanishta. Right. So let us move forward. Uh, and okay, so let's look at today's section. Okay, the Bharatiya Astronomical Model. Okay, so as usual, let's start with a fun question. Can you identify the structure shown in this logo?
Jantar Mantar.
Jantar Mantar.
Okay, perfect. I think I had initially wanted to go to what the logo was before I wanted to ask the structure, but that's fine. So this is the logo
Asian
of the
Games.
1982 Asian
Yeah.
Games, and this is Jantar Mantar. It is in New Delhi. Now, for those who may not know, the logo was inspired by Jantar Mantar, obviously. So for those who may not know, the Jantar Mantar is an astronomical observatory that was established in the 1700s, and the primary purpose of this observatory was to compile astronomical tables so that we can predict the timing and the movement of the sun, moon, and the different planets. Right. So the Jantar Mantar has several sections within it. Obviously, what you see here is the Samrat Yantra, which is the giant sundial for measuring the time of the day based on the shadow that the sun makes on it. But then it also is used to calculate many other uh, parameters, such as the altitude and the declination of the sun and the other stars and planets. It has uh, it also has something called as Mishra Yantra, right, which track the coordinates in a different coordinate system, which is the azimuth and the altitude. It is also used for predicting eclipses and solstices through the instruments that are calibrated there. And you can also calculate the local latitude using the instrument setups. Uh, so it is an example of our observational capability. This was in the 1700s. It's supposed to be very precise, and uh, of course, all throughout the tradition of Indian astronomy, as I keep saying, observation was a very important aspect, and we'll touch upon that in this class. So there's a certain reason why I had this question as well. So we'll touch upon that shortly, right? Okay, so that leads to what is the primary purpose of Jyotisha, right? I mean, why did we even have Jyotisha in the first place, right? So it's summarized through this one phrase, Dig, Desha, Kala, Jnana, right? Knowledge of direction, location, and time. Very simple, right? Dig Jnanam, so what is my east-west direction, right? That is the Dig Jnanam, knowledge of direction, right? Uh, and then you have Desha Jnana, right? Which is where am I? What is my location? What is my latitude, right? Or uh, what are the celestial coordinates with respect to a given observer? So where the question where is answered by the Desha Jnana. And then Kala Jnana, as the name suggests, is uh, the discipline that governs time. So at what point of time is a certain event happening, right? So that is so the entire purpose of Jyotisha can be summarized as trying to understand these three aspects. So all our observations and calculations were centered around trying to understand this, trying to uh, lay down frameworks, for example, like the Yuga cycles, right, to map time, starting from a large scale times like the Yuga all the way till very small units of time. Uh, so this was the core purpose of Jyotisha. So how important was this, right? So this was so important that unless someone knew this, he was not actually considered to be of any worth in Jyotisha, right? This is fundamental to the understanding of Jyotisha. So there is a sloka which is in Siddhanta Shiromani which talks about this, right? So it says Golan Abhigyo Ganakastha Tathatra. Anabhigyo. Golan Anabhigyo. That is a person who lacks the knowledge of Gola, right? Gola is the spherical astronomy, and then Ganaka, which is mathematics, right? So how is such a person? Such a person is Bhojyam Yata Sarvasam Sarvarasam Vinajyam. A dish without ghee, Rajyam Yatha Raja Vivarjitam. Kingdom where the king is not present, right? And Sabhana Bhativa Suvat Suvaktrihina. The gathering without a good speaker. So this is, of course, by Bhaskara, Siddhanta Shiromani. It says, it underscores the importance of having the astronomical and the mathematical knowledge uh, to understand the astronomy for astrologers as well. So this is even more significant in today's times, where all the calculations are now available as software, and people just directly jump onto predictions, right? That should not be the case. They should understand the mathematics and the astronomy behind casting of charts, etc., before they can start predicting, because only then their analysis of such astrological predictions are of any value. Right? So this is the primary purpose of Jyotiṣa. Right? Now, in the Bharatiya Astronomical Model, this this kind of coalesced into one problem, right? Where is the vernal equinox, right? So during the times of Vedanta Jyotisha, people had a, let's say, insatiable need for understanding where the vernal equinox point is lying into an accurate manner, right? So they set about understanding or calculate or finding out where exactly is this vernal equinox. So they spent a lot of time and effort doing that. The main reason is because they needed to fix the proper time for the performance of the ritual, right? So they used instruments. Specifically, they use this what we call as the gnomon. It's also called as the sundial. So the sundial is the complete instrument. The gnomon is the is this piece of rod or piece of metal that is placed, whose shadow, when it falls on this plate, provides an idea or very accurately about the time of the day, right? Now, using this gnomon, they were able to precisely observe the east-west directions. They were able to observe uh, at during the noon time, the position of the shadow. So they made a lot of observations. There's a lot of different kinds of observations that were possible using the gnomon, and using that, they made some derivations, right? So, for example, they did some correction of the east-west points, and from the east-west, they went on to find out what is the north-south. They adjusted for any parallax errors and so on and so forth. But then, as an end result of all that, they were able to very accurately pinpoint the position of the vernal equinox, right? So, just to remind you, vernal equinox. So, there's a concept of equinox and solstice, right? So, equinox is the point where the duration of the day and the night are equal. So there are two such equinoctial points in an year, one that happens in spring, which is vernal equinox, and the one that happens in autumn, which is the autumnal equinox. So vernal equinox happens during the time of Uttarayana, right, when the days are getting longer, and conversely, the autumnal equinox happens during Dakshinayana, the days are getting shorter. Again, this is all with respect to northern hemisphere. I think you can uh, draw the parallel to the southern hemisphere. I don't want to repeat that, but the idea was to pinpoint the position of the uh, vernal equinox, right? So they were able to precisely track the location of the equinox, and they were able to, not only that, they were able to observe that this vernal equinox was actually not a fixed point in space, right? So over the years, the vernal equinox does not always happen at the same background of nakshatras. It keeps changing. This is a very important observation that was made by our Indian astronomers, right? We'll come to that shortly. Okay, but why did they even need to know the vernal equinox in the first place? For various reasons, right? So, from a practical perspective, you know, I've listed down some of the reasons, right? For example, they want to know when should I celebrate my Makar Shankaranti, right? So I need to know. See, the vernal equinox is a 0 point or a reference point based on which they were calculating different celestial events that were happening, right? So one of them was where when do the festivals start so that they can plan for it. When should I sow my seeds, or when should I harvest, right? So these are key practical questions that they had. When should I start my rituals, right? What is the appropriate time? for starting the rituals, right? And then when will the eclipses, when are eclipses going to happen, so that they can plan accordingly. Uh, and this was also required for synchronizing the lunar and the solar calendars, right? So the solar calendar is based on the sun's transition into one of into the different rashis. Like there are 12 rashis. So the solar calendar is governed by the sun's movement into each rashi, whereas the lunar calendar was driven by Amavasya and Purnima, right? When sun and moon were in the same position at 0 degrees to each other or at 180 degrees to each other, which is the Purnima, right? So they needed to know this, and this also uh, the synchronization of the or the difference between the solar and the lunar calendar leads rise to what is called as Adhika Masa, which again we will touch upon when we touch upon the concept of time, right? So there were various reasons why they needed to uh, uh, pinpoint the position of the vernal equinox, because it is on the basis of the vernal equinox that they have to calculate the remaining uh, astronomical tables that were there, right? So the astronomical tables are all derived out of the position of the vernal equinox, right? Now, as I said earlier, the vernal equinox is not a fixed point in the sky, right? It They observed that it kept changing, right? So, by this observation over a period of years, uh, so they needed to understand why is this vernal equinox changing, right? That led them to the understanding of what we today know as the precession of the equinoxes, right? So, uh, precession of the equinoxes, right? So, what is precession of the equinoxes? Before we answer the question, let us briefly touch about the nakshatras in our astronomical model. Right? Now, the nakshatra system is, of course, is unique to Bharatiya astronomy. See, every civilization had their unique unique ideas and concepts. The nakshatra system was very central and unique to the Bharatiya astronomy, right? So, what is the primary purpose? The primary purpose is the nakshatras provided a fixed static background curtain against which the events are happening, right? So it's a while everything is changing, right? Sun is changing, moon is changing, etc. The stars that are all the stars provide a fixed reference point against which these movements are tracked. Of course, we know in today's modern astronomy that the distant stars are also changing, right? But those changes happen at far greater scales of time that that they considered that it was good enough for them to be a for it to be a fixed point of reference, right? Now, the ecliptic is divided into 27 segments called the nakshatras, right? It starts from Ashwini to Revati. I think all of us would have definitely been familiar with it through all the stars. Now, the question is, what is this ecliptic, right? So, if you go and stand on your terrace tonight, and if you look above the sky, you will see that the sun, of course, you don't see the sun in the night, but you see the moon and the planets. They all travel within a certain band in the sky. So they don't deviate from that band, right? So they always are within that band. Okay. So sometimes they may be slightly north and sometimes they may be slightly south, but then they are always in the band. Now, this band through which the movement of the sun, the moon, the planets happen is called as the ecliptic, right? Uh, and This is important because this is our, let's say, our observational scope, right? Now, this ecliptics is divided into 27 nakshatras, right? So, if you take the ecliptic to be 360 degrees circle, then if you divide it by 27, you get that every nakshatra occupies what is called as 800 minutes. So how does this 800 number come? Very simple mathematics. 360 degrees, just multiplied by 60, you get 21,600 minutes. So 1 degree has 60 minutes. And then if you divide it by 27, it gives you a straightforward 800. Right. So that's how the 800 number comes. And then each nakshatra is further subdivided into four parts called as padas. Right. So there are totally 108 padas. I mean, I think you would be familiar with saying that I was born in a certain nakshatra and a certain pada, right? So pada is a part of a nakshatra. And this entire 27 nakshatras, 108 padas, span the 12 rashis, starting from Mesha all the way till Meena. And by corollary, you will see that each Rashi has 9 padas, right? So some nakshatras will uh, cross the Rashi boundaries, right? I don't want to get into too much of detail on that, but for now, it is important. It is just important to understand that there is a fixed frame of reference in the background, which is the nakshatra mandala, and then each nakshatra spans a certain area of the sky, which is 800 minutes. And in the previous times, a 28th nakshatra called as the Abhijit nakshatra was included, but it was later dropped for whatever reasons. I mean, today we had Pluto as a planet few years back. Now Pluto is not considered a planet. So something similar to that happened many centuries back, where they decided that Abhijit is no more a star. So uh, because one of the reasons is attributed is because of the high latitude, relative to the ecliptic. So, like I said, so there's a certain band in which these nakshatras fall. Now, probably Abhijit was far away from the band, and someone revised that band or whatever reason, but it is not considered a nakshatra after a certain period of time, right? Now, one important point that I wanted to mention is, while we talk about the ecliptic nicely divided into 12 rasis and 27 nakshatras, it is not exactly like that, right? You can never say, exactly at this point this nakshatra starts and exactly at this point the nakshatra ends. So this was more of a convenience, right? So the length of the nakshatras were not even. Sometimes you could have a nakshatra that crosses is 800 arc minutes, and sometimes you could have a nakshatra that is very less than that 800 minutes. But the idea is there are 27 of them. The average nakshatra length is uh, 800 arc minutes, right? And by the way, you can actually map each of our Indian astronomy nakshatras to what we know as the constellations, or more accurately asterisms today. So, like Ajay was mentioning, we have Betelgeuse in Orion, which is actually Ardra, and we have several interesting nakshatras. So, in the constellation of Scorpio, there is Antares, uh, which in Indian astronomy is called as the Jyeshtha nakshatra, right? So, interestingly, Antares is a huge red giant star. Uh, it is estimated that there are the diameter of Antares star is 15 times the diameter of the solar system, right? And incidentally, Jyeshtha in our tradition is the eldest, right? So our ancient astronomers somehow probably knew that this was such a huge star. It was like the big brother star, that they actually named it Jyeshtha, right? So there are some many interesting such anecdotes which we can go on and on. But uh, so there is a mapping between every nakshatra and uh, its modern astronomical name counterpart that is there, right? So it's important to understand these the nakshatra system. And then I've also given for your reference the actual spans of these nakshatras, right? So Ashwini, which is at the beginning of Mesha, is 0 to 13 degrees 20 minutes. So every nakshatra is 13 degrees 20 minutes, which gives, by the way, that 800 minutes, because 13 into 60 is 780 plus 200 is 800, and all the way until Revati. Right? So just so in case you want to refer, you can refer to this. Right? Now, Uh, okay, so now what does our slokas talk about nakshatras? So, as expected, nakshatras have been acknowledged as early as Rig Veda, right? So, and like we have discussed before, Rig Veda in its true poetic, glorified form says that the Surya's bridal position, which Savita dispatched as advanced, the oxen, and all those metaphorical things, and in between he's talking about the Maga constellation, right? Uh, so it has been recorded. The nakshatras have been recorded as early as the Rig Vedic times, right? Similarly, in the Vedanga Jyotiṣa times also, again for the purpose of rituals, the nakshatras needed to be known, uh, and which is recorded through this sloka. The presiding deities of the astrosmos or the nakshatras are respectively Agni, Prajapati. So every nakshatra has a presiding deity, right? Which kind of adds a character to that nakshatra, right? So Agni is Kritika's deity, right? So it's interesting to see that this 27 nakshatra system actually starts from Agni, which is Kritika, and then ends with Yama, which belongs to Bharani. Right? So the system that was used at that age started from Kritika and ended up with Yama. Today, popularly, we consider the beginning of Ashwini as the first nakshatra, ending with Revati, and this also could be a effect of the precession of the equinoxes, right? Where uh, the starting point or the fixed point of reference was also changing through the ages, right? Now, when you come to Tantra Sangraha, which is of course, it was just hardly a few hundred years back, the same nakshatra is now being dealt with in a mathematical way, right? The longitude of the Lord of the night in minutes is divided by 800, and the quotient gives the number of nakshatras. He is getting very technical here, right? They are now laying down the framework for actually calculating uh, where the position of the nakshatra very precisely, right? How far is it from the fixed reference point and all that, right? Which is expected because that's the way Indian astronomy has evolved, right? Now, very interestingly, I just wanted to bring out this point, right? In the times of the Vedanga Jyotisha and probably later, while naming a child, it was customary to choose a name, the first letter of which corresponded to the nakshatra in which the child was born. And I think today also it is practiced in many families, right? Traditional families where certain nakshatras are attached with certain syllables. For example, the Magha nakshatra is attached with the syllable ma. So people tend to name their children born in Magha nakshatra as ma. And similarly, I think Kritika has like that, right? And when a person's nakshatra is not known, uh, they will take the syllable or the first syllable of that person and then say that his nakshatra is that for the purpose of the ritual, right? So it was vice versa. So I just wanted to call out that interesting fact because it was mandatory for the at the time of the ritual to say that I belong to this certain nakshatra and I am performing this yajna. So it was important to fix the nakshatra of the person, and one of the techniques that was used for was this. So I just wanted to kind of share that. Right? Now, just reinforcing what we learned a couple of classes, the same concept, the same phenomenon is a metaphor in the Rigvedic times. It is pinned to the yajna in the Vedanga Jyotisha time, and in the more relatively modern times, it is stated as a very precise computational idea, right? So I just wanted to kind of reinforce that point through this example as well, right? So now we have talked about the precession of we have talked about the nakshatra model, uh, and I just wanted a quick time check. Ajay, where are we?
We are 8:12 here, so yeah,
Okay,
18
fine.
minutes left.
18
So
more
we have about
minutes.
okay, we have about 18 minutes. So I'll pace it accordingly.
Yeah.
Uh, okay, now let's talk about the precession of the equinoxes, right? So what we observed earlier was our Indian astronomers knew that precession was happening, okay, and they recorded it as well, right? So this is Varaha Mihira recording the precession of the equinoxes. How? He says in Brihat Samhita, there was indeed a time when the sun's southerly course began from the middle of the star Aslesha and the northerly one from the commencement of the star Dhanishta, as we have just seen, right? As it has been so stated in the earlier works, right? Which is the Vedanga Jyotiṣa. However, at present, the southerly course of the sun starts from the beginning of Cancer and the other from the initial point of sign Capricorn, which means Varahamira gives the positions of the solstices during his time, right? Which means number one, he has understood what precession is. He has acknowledged the fact that the solstices will not happen at the same time. Now, number two, he also highlights the fact that he is just not blindly following the statements of what is written in Vedanga Jyotisha, but he was actually making the observations for himself and confirming that this is indeed where the solstice and the equinox are actually happening, right? And if we have to quickly go back to our diagram here, right? So remember we talked about how Aslesha Dhanishta was the solstice axis during the Jyotisha, Vedanga Jyotisha times. And we also saw this red line, which is the current era, or the current time where we saw last time using Jagannath Hora software that the winter solstice, the winter solstice or the Dakshinayana is happening at Mrigashirisha and the Uttarayana is starting to happen at Mula, which means the winter solstice is at Mula and the summer solstice is at Mrigashirisha. Now, during Varahamira's time, because he clearly states that the beginning of Cancer is when the Dakshinayana starts happening, right? Which is the beginning of Cancer is the Punarvasu Nakshatra's third pada, right? The third pada, I think. The fourth pada of Punarvasu. And then its opposite is the beginning of the Capricorn, which is Uttarashada, one pada remaining. So Uttarashada, fourth pada. So this is Punarvasu second pada, Uttarashada fourth pada. This is where the solstices are happening during his time. So he has very clearly recorded where the solstice is happening, and by that he has confirmed that he understood what precession is, and he is actually calculating that as well. Similarly, it was followed and tracked by all the different astronomers. So many Indian astronomical works talk about the phenomenon of precession. Okay, I think they give slightly different values of what is the rate of precession, but they are all centered around this 54 seconds per year. So what they're effectively saying is the axis of the Earth is not fixed, right? It is actually wobbling or it is changing at a rate of 54 seconds per year. So the axis of the Earth is actually shifting 54 seconds every year. It's falling back 54 seconds, right? So which means after a certain number of years, uh, the equinox point would have actually started moving across nakshatras and started moving across rashis also. Right? So that is why we see that the equinox point is shifting across different nakshatras, starting from the Vedanga Jyotisha time, to Varahamira's time, to the present time. Right now, To further understand this, right, we'll talk about what exactly is the precession of equinoxes. Okay, so we touched upon this very briefly in the last class, but the precession, it is like a wobbling of a top, right? So when the top comes to, so whenever a top that is spinning at high speed, the axis of rotation is fixed, right? It's always up, up, down, right? Vertical line. However, when the top is about to, it slows down and it's about to stop, it exhibits a wobbly motion. So the Earth also exhibits a wobbly motion, because of which the axis, right, which connects the North Pole and the South Pole is not fixed, but it actually changes every year because of this wobbly motion. So that is the idea of precession. And for the Earth to come back to the same point, it takes 26,000 years. So the one cycle of precession is 26,000 years. So first of all, why is this precession caused? It is due to the cumulative effect of the different gravitational forces that are exhibited by the sun, the moon, also by large planets such as Saturn and Jupiter. It causes this kind of wobbly motion, and uh, and let me see if this works. I tried. That's a good video uh, that talks about. Sorry. Are you able to hear the video by any chance?
No, the audio is
Audio,
not there yet.
audio is not there.
Video is not playing. It just
Okay, one
stopped.
second. Let me see if I can fix that. So or better is I will actually open it in YouTube and I'll show it. Okay. Let me try to share it with the audio as well. One second. Okay, share sound. Perfect. Okay. Uh, are you able to see my screen now? Where
Yeah,
it's open?
yeah, I can see a screen. Okay.
Can you hear the audio as well?
Yes.
Okay. Okay. So I just want to briefly pause here. Uh, See, we need to have some basic understanding of the coordinate systems, right? So this is the equatorial plane, right? And this is the ecliptic. So the ecliptic, like we discussed before, is the path along which the apparent movement of the sun, the moon, and the other planets happen. And you can see that the ecliptic and the equatorial plane are tilted at a 23 degree, 23.5 degree angle, right? Which is why the days and the nights are actually not equal at different latitudes of the Earth. Right? So let's go on. So you can see that this is the axis of the rotation of the Earth, right? Now, the North Pole of the Earth today points to what is called as the pole star, or what we call as the Dhruva Nakshatra, right? But that is only today. Because of the precession of the equinoxes, this position of the Dhruva Nakshatra also keeps changing. So you will see that in many astronomical works that there's a different Dhruva Nakshatra during earlier times, and there will be different Dhruva Nakshatras in the future as well, right? So that is another thing that we want to discuss. One more point I want to discuss is the point where these two meet, the ecliptic and what is called as the celestial equator, that is the vernal equinox point, right? Now, this vernal equinox point, because of this precession, see, if there was no precession, the vernal equinox point will always be at the happening on the background of the same star. But because the precession is also happening, this vernal equinox point is also shifting through the different background of the star. So that's the point that I wanted to make about the precession here, right? And we will see that shortly. Okay. Now this symbol gamma, or I don't know, whatever we call it, is the vernal equinox point, right? Now, because of this precession is happening, this vernal equinox point will happen in the background of different stars across a period of 26,000 years, right? And this is how it happens. So it was around 1000 BC in Aries. I think this is the beginning of Aries. Now, because of the precession, the equinox point has shifted to 180 in Pisces. You can also observe that this line through which we know the Polaris or the pole star today, that is also shifting. So the Dhruva Nakshatra or the pole star is also shifting through the ages. Okay. So I just wanted to kind of share that. You can have a look at this video. I will share it, right? Now, while we are on this topic, I also wanted to share something else, which is, so where is the vernal equinox point today, right? Uh, let me share that. Okay. So typically, the vernal equinox point coincides with the beginning of the year as per the Chandramana calendar system, right? So we celebrate Ugadi, for example, right? That is the that typically happens to be the vernal equinox point. So if I just go to the time for 2026 Ugadi, right, which is March 19th, 2026. Okay. So I see that the sun and the moon are in the Amavasya position, signaling the beginning of the Chandramana calendar
Madhu,
year.
Manu, you did not select India as the location, so it might not have been accurate.
I have selected Chennai, so that should
so that it becomes, just choose the rest of the world there, so that it gets it better. Yeah, India there becomes
okay.
accurate.
Yeah. So yeah. So yeah. So it happens in Uttara Bhadrapada at 4 degrees, right? The moon is somewhere around, right? Not exactly, but it's moon moves quite fast, so it's just a matter of time, a matter of few hours rather. So the point I wanted to make here is that the current vernal equinox is happening at the Uttar Bhadrapada, 4 degree Pisces. There are records that the vernal equinox point happened at the beginning of Mesha or at the Ashwini Nakshatra, somewhere around 300 common era, right? And if you do the mathematics of that of the 54 seconds movement per year, you can actually see that the vernal equinox today comes to very close to this value. So we are literally, and this point, as the years go by, will keep shifting further to the west, right? So after a few thousand years, it would have, it would have moved further west. So the vernal equinox will start happening when the sun is here, for example. And then after a few years, it will happen when the sun is here and so on and so forth. So the vernal equinox point in the course of the 26,000 years will actually happen at all the different nakshatras at the background. So I just wanted you to kind of understand the concept of this precession. Let me share my screen, the PowerPoint again.
Madhu, I think it's
Okay.
end of the hour.
Okay, no problem. Yeah, I think we can maybe take a logical pause for today, uh, and maybe we can take a few questions, comments, suggestions, observations.
This was very good, Madhu.
Yeah, thank you.
Yeah,
Any questions on the chat?
I
Chart
asked
was
a
clear.
question.
Sorry. 54. Okay, do we have a Tantra Sangraha dated? Please cover only if we have time. Okay. Tantra Sangraha is dated to, I think we discussed it last time. Is
Yeah,
dated
no, you showed
to,
that table, like say a chart, kind of
yeah, Tantra
graph.
Sangraha. Okay, interestingly, Tantra Sangraha is not there, but it was, sorry, it is there. It is 15th century, 1444, right?
14.
Yeah, so
Okay.
it's about 600, 600 years back from now. Uh, yeah, so it's about 54 seconds per year, right?
Yeah, so
Approximately.
is
See,
that then my calculations right then? So basically between 24,000 to 26,000, there's like approximately 4 second difference. I'm just kind of trying to figure out which one we
yeah,
should actually anchor on.
there is always a debate around it. That's the reason why we have different ionamsas. We'll touch upon ionamsa next class, right?
Oh,
So
okay.
it's
Okay.
actually not 26,000 years. It is say 25,700 years.
Yeah.
That is as per one model. But then different scholars are having different estimates of precession. Again, this is based on how they interpret the texts, right? So I have a
Mm.
chart that shows how this variation happens. But the normal accepted thing is 54 seconds per year, which is what modern astronomy, the likes of NASA and all that also are subscribing to. All right. So,
Okay. So
but
that
yeah,
means what you showed, then the Jagannath Hora is taking into account the 54 second drift in calculating the ascendancy then.
absolutely.
Yeah.
So when we use Jagannath Hora, we fix the
Anam,
Ainamsa,
Ainamsha.
right? Right.
Ah,
So
yeah.
we have taken the traditional Ainamsa called as the Nirayana or the Chitrapaksha, where it is along the Ashwini Chitra. So if you take the Chitra Nakshatra and draw a line, right? That line is taken as the vernal equinox point, right? For that's the standard Nirayana calculation. But then you can take the tropical time, Sayana also, right? Or you can take Ramanayanamsha, or there are some other Ayanamsha, this Ayanamsha. But based on that, the chart will change, the Lagna will change, and everything will change, and the predictions will also change based on that. Yeah. I think uh, Harini madam has a question.
Huh. Namaste. I just wanted to know if in the Ramayana, the entire Ramas in the Chaitra Masa Navami day and the Punarvasu Nakshatra. So I wanted to know if we can, use this to date the Ramayana based on the precisions and whatever the descriptions have been given in Ramayana during that time, because there was Abhijit Nakshatra in use at that time. So are we able to date Ramayana precisely with this info?
Uh, of course, this is. I'm not sure if we are able to see. There are. I'm sorry. First of all, am I audible?
Yes,
Yes,
yes.
yes.
Okay, okay. So yes, we have used these astronomical markers to date Ramayana and Mahabharata, right? Also, I think especially Mahabharata, there are a lot of debates that I can see that are happening online as to when Lord Krishna died. But I don't think there is any conclusive. It's a subject of research as I understand it today. So I don't. I at least I am not aware of any conclusive research on this. There are different uh, researches that are going on on this.
Yes.
So what I can tell you
Okay.
is, see, from the astrology community, right? The again, it's a matter of the interpretation is very can be in different ways. That even the horoscope of Rama is a matter of debate. So some people, based on the sloka that Valmiki has provided, fix Mercury to be in Aries, whereas some scholars like K.N. Rao fix Mercury to be in Pisces, right? So it's very vague. It's highly subject to interpretation. I think the timing efforts are also going on, but I am definitely not a expert on that. I don't know much about it, to be honest, but I can do some work on that. I'll get back to you in the future.
Okay.
Right.
And I think Nilesh Oak, he has done one
Yeah.
calculation based on
Yeah,
that.
Nilesh Oak and NN Pandit.
Yeah, so for the Raman, he's put it at 12,000 odds BCE, somewhere in that range. But I think one of the issues is interpretation and the fact that those conditions might repeat in certain aspects. So I think there are lots of matching that you have to do in order to get the dates right, and that's always open to interpretation.
Okay.
Yeah, we don't
That's
have.
actually there is a documentary. Sorry.
Go ahead.
Go ahead. Go ahead.
No, go ahead. Ram, go ahead.
So there is a documentary by this channel called Prachiam
Yes.
on his book dating Mahabharata, and that sounds plausible. Where there were explanations given backing the astronomical archaeology to essentially meteorological astrology, and at least around probably 10 of them were listed. 7 or 8 were sounded pretty credible from in dating specifically the Kurukshetra war. I don't know about Ramayana. I haven't seen or read his book about the Ramayana, but at least Mahabharata sound very plausible. I think he dated it back to 5,361, I believe.
5561, I think he. Yeah.
5561, is it? Okay, yeah.
See, the Vedanga Jyotiṣa.
Mahabharata is straightforward, no, because Kali Yuga starts that day, and every day, every Hindu says that every day, Kali Yuga, Pratame Pade, and all that. So you are getting that date from for Kali Yuga. It is so Mahabharata is not a big thing. Actually, Ramayana is, I think, more confusing.
Yeah. So
Okay. Oh.
even see Vedanga Jyotisha, right, which is an astronomical body of text
Text.
itself, right? It has different clues as to when it was authored, right? Like we discussed about solstice happening in Dhanishta and so forth. So it has, but even that, there is a disagreement between scholars as to what the date is, right? Where things are a little bit more concrete and specific. Now with Ramayana, I don't think we have very specific astronomical markers. So which means the margin of error in Ramayana is much higher and subject to a lot of interpretation, right? And hence you see that a lot of debates have been. Now there is a different school of thought which says don't even try to date the Ramayana because it happened in Treta Yuga, which was 43 lakh years back. So don't even, but that's a different topic altogether. Assuming that we can historically trace back also, there is a lot of interpretative error that is there in Ramayana. Yeah. I think Mahesh, sir has a question.
Yeah, I just following up on what Hariniji asked, that Ramayana also has multiple authors. We have Tulsidas Ramayana, we have Valmiki Ramayana, we have Kamban Ramayana. I don't know whether they are all unlike Mahabharata, which is only by Veda Vyasa. So there may be, and the fact that Valmiki was not a historian, he was a poet. So I don't know from all that perspective, because I don't know whether within all these 3 or 4 Ramayanas, whether everything, I know descriptions, there are differences, but I don't know these astronomical markers are also different. I don't know.
Yes, but clearly the original Ramayana was the Valmiki Ramayana. But anyway, I think the whole archaeoastronomy thing is a little bit hard to interpret and bit beyond.
So it was a good question for Hariniji.
Yes.
It was a good question.
Absolutely, absolutely. I think it's a much bigger topic of research,
Yes.
in a wider community.
True.
Okay. So what we can do is, right. So in the next class, we will take the first few minutes to kind of close off this topic, and I think we will be back to Ajay talking about some stories and metaphors, and we'll take a little bit break from the technical mathematical part of it, which we have covered in the last couple of classes. I hope that's okay with everyone, right? Okay.
Thank you.
All right. Thank you for attending today's class. Have a good day.
Thank you, folks. Thank you, folks.
Thank you.